3 minutes ago, the silence of the cosmos was broken. A new object, designated C/2025 V1 Borisov, was spotted drifting in the void between Earth and the path of our last interstellar visitor. It's bizarrely bright, yet almost completely tailless. A combination that seems to defy the known laws of cometary physics, and it's leaving experts completely stunned. Is this the start of a cosmic collision, a rare celestial alignment, or something else entirely? Let's delve into what we know. Discovery Night. How does one person, using a telescope they built themselves, trigger a global astronomical event overnight? On the evening of November 2nd, 2025, that's exactly what happened. At the Margot Observatory in Crimea, astronomer Gennady Borisov noticed a faint unfamiliar blur in his nightly imaging sweeps. He watched it move against the backdrop of fixed stars, its path just slightly off from the usual tracks of main belt asteroids. This name should ring a bell. In 2019, Borisov made history by discovering 2I/Borisov, the first confirmed interstellar comet, using his own custom-built equipment. Now, 6 years later, his sharp eyes and homemade optics have flagged another cosmic outlier. Within hours, he reported the new object to the Central Bureau for Astronomical Telegrams. The initial data was precise: a brightness of magnitude 12.1, a diffuse coma nearly half an arc-minute across, and most importantly, no sign of a tail. This final detail was the most critical, as a tailless but active object suggests an unusual composition, a puzzle that cometary experts like Michael Yeager live to solve. The object was provisionally tagged, signaling to the global network that something highly unusual had just entered our cosmic neighborhood. Global alert. When a single alert from a credible source goes out, how fast can the entire planet turn its collective eyes to the sky? In this case, the answer was just hours. As word of Borisov's discovery spread, observatories from Japan, Ukraine, Russia, and the Canary Islands raced to confirm the find. Digital images and brightness measurements flooded into official databases and online astronomy forums. The consensus was immediate and clear. Team after team reported the same bizarre features that Masayuki Iwamoto, another famed amateur comet hunter, would recognize: a condensed, brilliantly bright coma, but no discernible tail. Out of the first 10 independent observations, only 2 hinted at a faint, inconsistent tail-like structure, details that were quickly attributed to image processing artifacts. By November 3rd, the discovery was officially confirmed by the Minor Planet Center. The provisional tag was replaced with its formal name, C/2025 V1 Borisov. With that name came a call for urgent, continuous follow-up, turning one astronomer's sharp-eyed catch into a relentless, international campaign. This rapid, decentralized verification process is the hallmark of modern astronomy, a system that planetary scientist Sarah Seeger has championed as essential for tracking fast-moving celestial events. Rapid brightening. An object that gets 100 times brighter in just 5 days isn't just unusual, it's a signal that something powerful is happening. But a signal of what? When astronomers at the Palomar Observatory checked archival survey frames, they found the earliest trace of C/2025 V1 Borisov from October 29th. Back then, it was a barely there smudge at a faint magnitude of 17.5, but by the time it was confirmed on November 3rd, it had surged to magnitude 12. This leap of more than 5 magnitudes represents a nearly 100-fold increase in its visible light, an outburst that set off a firestorm of activity among astronomers worldwide. This kind of rapid, intense brightening is a subject that cometary expert David Jewett has studied for years. Sudden outbursts can happen when a fresh patch of ice is exposed to sunlight, causing violent sublimation. But those events usually produce a massive, expanding dust cloud and a distinct tail. This object, however, just kept getting brighter while its coma remained sharp and compact. This behavior is more akin to the mysterious centaurs he studied, objects that blur the line between asteroid and comet. It was an unprecedented event that pushed the object into the viewing range of modest backyard telescopes, and the mystery only deepened. 3 paths. Things are not always what they seem in the sky. An apparent close encounter can be a grand illusion, a trick of perspective covering tens of millions of kilometers. By the pre-dawn hours of November 7, 2025, the sky presented a fascinating but deceptive picture. C 2025 V1 Borisov, the interstellar comet 2B-I Borisov from 2019, and a third comet, C 2022 E3 ZTF, were all tracing separate arcs through the inner solar system. From our vantage point on Earth, the new object and 2I Borisov appear clustered together in the constellation Virgo. But the reality, confirmed by orbital models from experts like Paul Chodas at NASA's Center for Near-Earth Object Studies, is a vast spatial gulf between them. On November 7th, C 2025 V1 is the closest to us, at roughly half the distance between Earth and the Sun. Its path is bringing it upward from below our orbital plane. 2I Borisov, on the other hand, remains far out in the solar system on its hyperbolic escape route. They are nowhere near each other in three-dimensional space. The apparent alignment is a pure line-of-sight coincidence, a temporary illusion that exists only in our sky. It's a powerful reminder from orbital dynamicist Renu Malhotra's field of study that the cosmos has depth, and flat sky maps can be deceiving. Dawn Watch. For the next few nights, the pre-dawn sky is offering a rare and challenging celestial showcase. Here is exactly how you can see it for yourself. The constellation Virgo, which dominates the southeastern sky, is the main stage. C 2025 V1 Borisov rises about 2 hours before the sun, holding steady at a magnitude that puts it within reach of an 8-inch or larger backyard telescope under dark skies. It appears as a soft, round, condensed glow. Just a few degrees away, you can find the location where 2I Borisov passed years ago, a ghostly reminder of our last interstellar guest. Visually comparing the new object to reports of the old one reveals the same stubborn tailless appearance. The best time to view is in that final hour before twilight begins, when the sky is at its darkest. Comet expert H.A. Weaver, who used the Hubble Space Telescope to get stunning close-ups of other comets, would tell you that this visual information is critical. The subtle differences in brightness and coma structure are clues to the object's composition. Using a low-power eyepiece to get a wide field of view is your best bet for spotting the faint, fuzzy object against the star field. These ground-based observations are the first line of data, the foundation upon which all other analysis is built. Missing tails. A comet without a tail is like a ship without a wake. It seems to violate the very physics of what a comet is, forcing us to ask a fundamental question: what is this thing actually made of? Both C 2025 V1 Borisov and 2I Borisov before it have defied the textbook image of a dirty snowball. To understand why, we have to look at the physics of its dust, a specialty of astronomers like David Schleicher. The key factor is a value called the beta parameter, which measures how strongly sunlight and the solar wind can push on a dust grain. For small, lightweight particles, the push is strong, and they get blown back to form a classic sweeping tail. But for dust grains larger than a few microns, that force becomes too weak. These heavier, more refractory particles get lifted off the nucleus by sublimating gas, but sunlight can't push them away. Instead, they linger close to the nucleus, forming a dense, bright, and spherical coma, but failing to stretch out into a tail. This suggests a composition low in the fine-grained silicates common in our solar system's comets. This, combined with a high phase angle that amplifies forward scattering of light, creates the bright, tailless apparition we are currently witnessing, a true outlier in cometary science. Brightness puzzle. Here is where the story gets even stranger. One of our visitors isn't just tailless, it's about 4 times brighter than it has any right to be. We're talking about 2I Borisov, which on its pass through our system continued to defy expectations. Photometric data consistently placed it at a magnitude significantly brighter than what standard light curve models predicted. This wasn't because of a visible outburst, its coma remained compact and sharply defined. So, what was causing the extra brightness? This immediately brings to mind the mystery of Oumuamua, our very first interstellar visitor. As astronomer Marco Micheli proved, Oumuamua showed a tiny but distinct non-gravitational acceleration, a push from something other than gravity. While 2I Borisov's deviation was much smaller and harder to confirm, it fueled intense speculation about exotic ices like nitrogen or carbon monoxide, sublimating differently than water ice. The leading theory is that these objects are made of less volatile, more refractory materials, possibly enriched in carbon, which behave differently under solar radiation. The numbers simply don't add up with a standard comet model, making this brightness anomaly, as planetary scientist Karen Meach would attest, one of the most intriguing puzzles of all.
Waiting for images.
We have thousands of dedicated eyes on the ground, but, the definitive answers to the biggest questions are really waiting in orbit. So why aren't our most powerful space telescopes looking yet? In early November, China's Tianwen Mars probe released a short, low-resolution video clip of C2025 V1 Borisov. It confirmed a bright coma, but honestly, it offered no new details, leaving key questions unanswered. The delay in its release highlights the challenge of getting timely data from major space agencies. All eyes then turned to NASA's Mars Reconnaissance Orbiter, Hubble, and the James Webb Space Telescope. Calls for high-resolution images are growing louder, with multiple target of opportunity proposals submitted. But as of this week, none have been scheduled. This isn't censorship, it's just the slow, grinding reality of mission priorities and technical planning. Planetary scientist Heidi Hammel, a veteran of securing observation time on these very telescopes, knows this process well. Pointing a billion-dollar observatory at a last-minute moving target requires immense coordination and displaces other long-planned projects. There's a bottleneck, and the answers we need about this object's true nature remain just out of reach, locked behind institutional review boards and the slow pace of space bureaucracy.
Solar storms.
A massive solar storm is currently sweeping across the inner solar system. It's honestly the perfect natural experiment, a blast of solar wind and radiation that should force any active comet to show its true colors. So what happens when the storm hits our mysterious object? And it does. Nothing. Geomagnetic indices have been spiking, with auroras visible at lower latitudes than usual. This is exactly the kind of event that solar physicists like C. Alex Young from NASA study. For a typical comet, this intense solar activity should dramatically enhance tail formation, or even trigger a disconnection event, where the entire plasma tail is ripped away by the magnetic field of the solar wind. Yet, for C2025 V1 Borisov, observers around the world have reported no major changes, no sudden tail, no brightening, no dramatic shift in the coma's structure. The lack of response is, well, deeply puzzling. It suggests the object is either far more resilient than a typical comet, or it's made of something that simply doesn't interact with the solar wind in the expected way. Every hour the storms continue, the mystery of its silent passage just deepens.
Testing predictions.
The internet is already buzzing with wild theories, ranging from a new class of natural object to, well, something else entirely. But speculation is cheap. The only thing that matters is the data. Here are the clear, testable predictions to watch for. Some, like theoretical physicist Avi Loeb, would argue we must be open to extraordinary possibilities for interstellar objects, but even he insists on hard evidence. First, we would look for sudden changes in trajectory or any non-gravitational acceleration that cannot be explained by simple outgassing. Second, we'd watch for a fragmentation event that doesn't match known cometary physics, perhaps breaking into geometrically clean pieces. Third, any abrupt and unexplainable shifts in brightness or color that don't correlate with its distance from the sun. And fourth, perhaps the most telling, would be any coordinated changes or communication between this new object and the path of our previous interstellar visitors. As of right now, absolutely none of these have been observed. The current data, analyzed by teams including astronomer Ye Quanji, shows a stable orbit and a stable coma. Until that changes, the evidence points to a natural, if exceptionally strange, new visitor in our cosmic neighborhood. So, here we are. A new object has appeared in our skies, discovered by the same legendary astronomer who found the first interstellar comet. It's too bright, it has no tail, and it's ignoring a solar storm that's raging around it. We are watching a scientific mystery unfold in real time. A story driven by a global network of observers on the ground while we wait for our most powerful eyes in space to take a closer look. The cosmos is not done surprising us. For now, every unanswered question is a reminder that discovery is no longer rare. It is relentless. We'll be tracking this story as it develops. Don't forget to like, subscribe, and hit the bell icon so you don't miss the next update. Stay curious, and thanks for watching Space Facts.